As the Orion spacecraft slips out of the Moon's gravitational sphere of influence, its speed climbs. The capsule is now locked in a freefall, accelerating rapidly back toward the center of Earth's gravity well. On the morning of Wednesday, April 8th, the crew wakes up at 11:35 a.m. Eastern Time. They are beginning the busiest stretch of the mission, a high-tempo period dedicated to preparing the ship for the trip home. For the last week, Orion has functioned as a deep space laboratory where astronauts could float by the windows and photograph the lunar surface. Now the crew must transition from that research phase to the physical realities of atmospheric re-entry. Flight Day 8 is when the mission profile pivots. Before they hit the atmosphere, the crew has to physically reconfigure the cabin, shifting Orion from an open-concept laboratory into a hardened survival capsule. The first major operational test begins at 8:15 p.m. when the crew executes their radiation storm shelter drill. Beyond the protection of Earth's magnetic field, the astronauts face high-energy particles from solar particle events and ambient galactic cosmic rays. Without shielding, this ionizing radiation can damage human DNA. To block these particles, the crew constructs a bunker inside the cabin. They stack dense materials, like the ship's water tanks and cargo bags, to create a physical barrier that absorbs the energy before it reaches the crew area. Effective radiation protection involves more than the ship's aluminum hull. By manually stacking their supplies, the astronauts turn the cabin's internal geometry into an active defense system. Later that evening, Commander Reid Wiseman and pilot Victor Glover take manual control of the spacecraft to test its handling qualities in deep space. They are evaluating the attitude control system across two specific modes. These include 6 degrees of freedom, which allows for combined translation and rotation, and 3 degrees of freedom, which is limited to pure rotational pivots. These tests confirm that the thrusters still respond precisely to manual commands after a week of exposure to extreme deep space temperatures. This data ensures the propulsion system hasn't degraded during the transit. Validating these manual controls provides the baseline for future missions. This handling data will inform the software and procedures needed for the complex lunar dockings required on Artemis II. Inside the cabin, Commander Wiseman begins the final stowage protocols. This includes dismantling and packing away the heavy flywheel exercise device to clear the floor. This lockdown is required to survive the physics of re-entry. When the capsule hits the atmosphere, it will decelerate sharply, subjecting the interior to forces up to 7 Gs. At 7 times normal gravity, any loose item, like a tablet, a digital camera, or a piece of exercise gear, multiplies in relative weight. If left unsecured, these objects become projectiles inside the confined cabin. Stowage also affects the ship's flight path. To maintain aerodynamic lift during its high-speed re-entry, Orion's center of gravity must be precisely balanced. If the internal mass is off-center, the capsule cannot stay on its target trajectory. By 3 a.m. on April 9th, the crew completes the cabin lockdown and begins their sleep period. When they wake up for Flight Day 9, the mission focus moves from the ship to the human body. Their first task is testing orthostatic intolerance garments. These are specialized, tight-fitting leg suits designed to be worn under their flight gear during the return to Earth. After 10 days in microgravity, blood supply shifts toward the head. Upon re-entry, gravity causes that blood to pool in the legs, which can lead to dizziness or blackouts. These garments apply physical pressure to the lower body to keep blood flowing to the brain. The work on Flight Day 8 marks the transition from deep space navigation to survival. By validating these procedures under the load of a real mission, the crew provides the data needed to secure future lunar landings.